Yeah, so before we start about talking our roadmap and what we are working on, what we're going to plan, I think it's important to understand where we are as a project. And an important metric for any technology is are the adoption metrics, right? But I think in the build and automation domain, which is very conservative for good reasons, those metrics are even more important. So if you set out as a build tool and say we want to become the new market dominant build tool, you need to reach or you need to make the mainstream confident that your technology is around in 10 or 15 years. So that is often the lifespan of the technologies we are replacing, right? So you don't easily change your build for when you have a 500 developer team. It affects every developer, and it affects your very capability of shipping software. So the other thing, people need to be sure that the problems they have been successfully solved with the same technology somewhere else, right? It's the whole crossing the chasm is for build systems even harder than for other technologies. So the threshold of entry into the market is very high if you want to become the new dominant build tool. And I'm super excited that Gradle has more than mastered this hurdle, and I want to share some data with you to demonstrate that. This number is from July. Just in 2014 until July, we had 1.5 million downloads. It's now more than 2 million downloads. So we had a record month in August with 350,000 downloads. So that is pretty amazing. I mean, we release every 6 to 8 weeks. So of course that increases the number of downloads, but however you see and interpret the numbers, it's a lot, right? So let's see how Google measures the momentum of the Gradle technology. So based on their search queries. So Gradle is in red, and you can see that there is obviously very strong momentum. But it's also serious substance. So if you compare this with other established technologies, like let's take Cloudera, right? You see also the substance in there. It's hard to compare it with Ant, right? Because Ant is not just a build system. And even if you compare it with Maven, there is the Mars rover and stuff like that. So if you compare it with Apache Maven or Apache Ant, Google is pretty smart. Gradle is definitely way ahead of that. But as I'm not completely sure about their algorithm, whether they can translate every Maven build system related query to Apache Maven, I thought I use a term that is less ambiguous of a different technology. So I wouldn't mind if this were also the revenue of Gradleware compared to Cloudera. Not yet. Okay, a good indicator of the momentum of a technology are also the books that are written for this technology. So there is now a nice library of books out there, coming mostly from the community, right? It's not like, we have been always a super small company. We could not push that, right? This is viral growth. This all comes, or to 99% comes from the community. I think Ken Cousin is also presenting here at Spring One. I think he's the author of the upcoming Gradle for Android O'Reilly book. There are more books in the making, so we are very excited about that. I discovered recently that olo.net, who has ever used that platform to learn about open source projects? I used it years ago and was kind of, for me, more like a toy. But this has really grown into a very interesting and complete database for open source project analysis. So they really include everything from Chromium, Mozilla, down to very small open source projects. So, and here's what Chromium says about Gradle. So very high activity, of course, yeah. So over the past 12 months, 80 developers contributed new code to Gradle. This is one of the largest open source teams in the world. Right? And over the entire history of the project, 159 developers have contributed. So that also shows another important point. Although Gradleware, our company, is a driving force behind Gradle, Gradle is a true open source project. right? Not just by license, but also by culture, with many people getting involved that are not part of the company. So, and we are just talking about the Gradle core here, right? We're not talking about all the external Gradle plugins. We talk about that later. This is just Gradle core. So if you look at the plugins, there are 200 plus listed community Gradle plugins out there that are really maintained and do a job. There are definitely thousands of experimental Gradle plugins out there. So this number is growing fast, and I have a dedicated section on that later. So the Rebel Labs, the guys from the JRebel folks, they published a couple of weeks ago the result of a recent survey, which was about the whole developer tooling ecosystem, including languages, CI tools, IDEs. And from all technologies covered in that survey, Gradle has the highest number when asked what technology in a particular field you are most interested to learn about. So 60% of 2,000 participating developers mentioned Gradle in the build tool segment, that they want to learn more about that build tool. So yeah, great numbers for us. And I think it is important to understand that context before I talk about what we're trying to do. So to close the section, there has been finally, now we're getting pushed on the good old the server side. There's been an article, when did Gradle get so hot? So we now definitely have entered fully the mainstream when you're at the server side. Okay, so Gradle 2.0. We had our second major release with Gradle 2.0 in July, and we've just released Gradle 2.1. So the way we deliver software is with 6 to 8 weeks release cycles. Right? So we're doing all the work in a master branch. That means major releases are usually not very sexy. They're just another minor release when it comes to new features. Right? But they serve two additional purposes. So when we do a major release, we use this as an opportunity to remove some of the deprecated features to reduce our maintenance burden. And the other reason why we do that is it's a means of communicating that the aggregate of all the features that we have added over the minor releases, or since the last major release, constitute a major progress that we want to express with a new major version number. So a key theme for 2.0 was maturity. Right? So Gradle got hardened by some of the largest builds on the planet. So at LinkedIn, for example, they have a 4,000 sub-module Gradle build, 1,000 developers running there multiple times a day. Right? So yeah, Netflix is a big user, many large corporate users. There's the Android community where we got valuable feedback. So from 1.0 to 2.0, Gradle got massively used in very complex and challenging scenarios. We got a lot of feedback out of that. And so Gradle 2.0 is in many ways an evolution of 1.0, plus some very cool new features. So would like to talk about that a little bit. So performance has been a very important area of improvement. So we touched many areas of Gradle to significantly improve the raw performance for the major usage scenarios. So we have a performance test suite. So those are the names of those tests. And we make sure that, this captures all performance regression. So we make sure that with every Gradle release, the performance definitely does not regress, or usually gets better with every release. So if you compare the 2.0 performance with the 1.0 performance, those are percentage numbers, we have improvements between 20 and 70%. So scenarios are clean versus incremental builds, project with large and small dependency graphs, large and small code bases. Performance has many facets when it comes to build system, and we try to capture all the major facets with our performance test suite, and those are the results. So those are really significant improvements between 20 and 70%. When we started with Gradle at LinkedIn, every LinkedIn developer box has 16 cores and 64 gigabytes of heap space. And it was not enough for their Gradle build. So, I mean, it's a massive beast what they have, but yeah, so we worked also hard on improving memory consumption, and the numbers are even more interesting or more impressive than for the performance. So we really got it down. At the moment, they're now down to 25 gigabytes. It's still massive. I mean, it's a massive build, 4,000 sub-projects, but we want to get it down another order of magnitude, and we'll talk about that later, how we're going to achieve that. So what we did with Gradle was basically taking what's there, taking the design decision we made with 1.0, and within those degrees of freedom, improve what we could improve. So who of you is having a kind of larger Gradle submodule build? Let's say 50 or 100 submodule Gradle build. No one. Okay, so so when you do, so let me ask another question. Who of you is using Gradle? So, I mean, we have a strong focus with Gradle on medium to large software projects. So we have many larger multi-module builds out there. And one problem we have with Gradle that we address to some degree in 2.0 and will address in a much more comprehensive way in 3.0 is that configuration times take too long. So you have all those Gradle build scripts, right? And whatever you do, even if it's just a clean, the whole build script is executed and sets up the whole model, and then we figure out, oh, you just want to do the clean, and we only need a subset of the configuration. With multi-module builds, that's even more extreme, because every build script of every submodule is executed before we execute the build. So we improved that situation a little bit, that we said, okay, we introduce a configure on demand feature that based, if you only want to do a partial build, if you only want to build, if you have only one sub-project out of the 100 sub-project, we have provided some means that then only this one project is configured, saving a lot of configuration time. So with LinkedIn, to give you an idea, with the 4,000 submodule build, it takes 1 or 2 minutes to configure the whole thing. Considering where they come from, their end build was taking 5 hours, their new full Gradle build is taking 45 minutes. For them, it's still wonderful improvement, but that's not the end, right? Definitely not, it's just the beginning. So the other thing we have started to provide during the 1.0 stream is parallelization per project. So you can run now parallel builds per project. You can now run parallel builds. But the parallelization is not on the task level, it's on a sub-project level. So LinkedIn is using that every day, that is production ready. It requires, though, that you use Gradle in a specific way. So it's more fragile than we want it to be in terms of how the build logic is organized. But at least it's a valuable feature and definitely significantly improves the performance. So another major focus for us was also dependency management. So we continuously improve dependency management capabilities to make it the best in the industry. So one thing we introduced, which I'm pretty excited about, are dependency resolve hooks. So they give you a powerful toolkit to model the resolution process. So for example, with classical POM-based dependency management, there's no way that you can say, okay, by the way, Spring All, I mean, it doesn't exist anymore, but in the old days, Spring All and Spring Core, they are related. They are not completely separate artifacts. So if you have a Spring Core to 1 and a Spring All to 2, don't put them both in the class path. Treat them as something similar, and then choose the one with the newest version and things like that. The same is true for Groovy All and Groovy Core. So we now provide you hooks that you can express those facts. Or for example, your company went through some acquisition, and your library com.foo 1.0 had to be renamed to com.bar 1.1. But it's the same thing, right? It's just for legal reasons you have to rename it. Those things you are now able to express in Gradle. You said, this is the same stuff. Please do version conflict resolution properly. Another thing we did with dependency management is we did this together with Netflix, is that we consider custom metadata a part of the dependency resolution process. So we are building up a framework that you can add any property to your custom metadata, whatever that is. Let's say where your library is in a staging process, QA, capacity testing, and whatnot. And then you can say something like, give me the latest version that has gone through capacity testing, right? So you can model the staging process, for example, with this toolkit very elegantly, right? So further work on dependency management will be another focus for the 2 Extreme. I'll talk about that later. We introduced a very elegant solution for many task ordering issues. So check it out if you haven't done yet. Should run after and must run after sounds innocent, but we think it's a major innovation to the executional model of build systems, right? This is about situations where let's say you have, you create a distribution, and part of the distribution creation process is running all the integration tests and also creating the documentations. Both are very time-consuming processes. So what you want to make sure is that when the distribution is built, you want that the integration tests are run before the documentation is run, because you want to get a feedback as early as possible. Documentation usually always works, but integration tests are the fragile part. So, but on the other hand, you can't say documentation depends on integration tests. That's not true. If you just build the documentation, you don't want that the integration tests are run before that. So with should run after and must run after, we now give you elegant tools to say, if the distribution is built, then the integration test should run before the documentation is built, right? So just to improve the way you get feedback and to give you earlier feedback without doing hacks. In the old times with Gradle, you had to then say, okay, then integration test must be called A integration test and documentation must be called B documentation, so that by alphabetical order, then this kind of works, but that's super hacky. But how would you solve that with AND, right? There's no way. So that is really innovation in the area of the DAG, directed acyclic graph programming. So yeah, Android, as most of you probably know, Gradle is the build system of choice for Android. We're super excited about that. That gives a lot of momentum to the technology. And the Google team is working on the Android plugin, right? But we have a close cooperation and adding features to the core that they need to provide a good experience. Another area where we invested a lot of time for Android is in our tooling API. So the tooling API is a bridge between Gradle and the IDEs, right? So and part of the Google Android toolchain is Android Studio, which is a new Android IDE based on IntelliJ, right? So it's open source and also maintained by the Google Android team, so not by IntelliJ. And their vision is to have an extremely deep integration with the build system. So their vision for IDEs is the IDEs shouldn't be a build system. IDE shouldn't do any build action, shouldn't compile, shouldn't run test. It should just visualize that, right? And everything else should be done by the build system. And we agree with that vision, but I would say the legacy build systems would have a hard time to kind of enable this vision. So we work closely with Google Android to make that possible. For example, what we will soon implement with the tooling API is a feature that you can run your tests from the IDE via the tooling API, but the tests are executed by Gradle, but there is a rich eventing system that the IDE can provide you nice visualization as you expect, but the tests are actually run with Gradle, which is really cool for integration tests. So I know many projects that say if you want to run your integration test via the IDE, read the build wiki, and then they tell you, well, go to the command line, run this end task that sets up the test fixture, run this Maven goal to set up the test fixture, then go back to your IDE and run the tests, right? So the whole test fixture management, you can't extend the IDE for that. So by making this much more integrated, this, especially for functional testers, will provide you a much better experience. So a lot is going on in that direction, and we're excited about that. And of course, all the other IDEs, so the plain IntelliJ integration and the plain Gradle Eclipse integration, will benefit from the work we are doing there. Gradle 2.0 means also a world-class native build system for C, C++, and assembler. So this is, for us, a new, only for us, it's a new software platform. We are fully embracing with unique capabilities. I will talk more about that later when we come to the 3.0 roadmap. Native is anyhow important, but it's becoming more important now because of all the mobile software, which requires many native extensions, right? So, yeah, so that was my presentation on the Gradle 2.0 features, right? So now, before we come to the roadmap, let's talk about the state of the industry when it comes to the software production process, when it comes to the build infrastructure. And I was thinking how to proper visualize the typical situation of 50+ developer teams when it comes to their build infrastructure. So who of you works in a team with more than 10 developers? Right? Who has more than 50? Okay, so I was thinking how to proper visualize the typical situation of 50+ developer teams, and that is a situation for the build master, right? So and I really feel with those teams, right? They have a lot of pain, and what I can only say, invest into your build, right? That is the current state for the majority, whatever that build is, right? Invest into your automation. The current state for the majority of organizations is not very good, right? So quite a few organizations have started to take sufficient actions to improve. Many take some action. So I would say there are some companies that have an extremely efficient software delivery process. LinkedIn is one of them. Google is one of them. Netflix is one of them. But if you see how they did it, first of all, they have super smart people, and second, they invested a lot of resources into that, right? So we're talking about a LinkedIn team of 100 people. 100 people, so 10% of the developers work on tooling for making the software delivery process more efficient. That's a discussion. Yeah, that's something you need to convince your manager about, right? And those are engineering-driven companies. In my experience, if you would tell a manager from, let's say, an insurance company from the East Coast, 10% of our developers should work on that, the guy would look at you and think, are you crazy, right? So for them, it is worth it. I will show some numbers soon. But it is our goal, basically, the goal of Gradle, to bring to, let's say, the majority of the enterprises what those companies are able to pull off with a lot of investment. We want to bring it to the enterprises in a way that it requires much less investment. So it is fascinating, though, when you look at enterprise builds, how people and teams get used to pain, right? Even if it costs them dearly. So, for example, we were involved with a large team on the East Coast, distributed Northern America, India, 200 people. They were having a legacy, or I shouldn't call it legacy. They were just having a 10 to 15-year-old software stack, producing a single ear deployed to IBM WebSphere. Creating that ear took them 6 hours. So now imagine if that takes 6 hours, what is going to happen, right? So 100 developers producing code continuously. So something goes wrong after 5 hours. And they say, damn, something broke the build, some test failed, whatever. They didn't have that many tests, but it's another problem. So now someone said, okay, what broke the build, right? And someone fixes the reason that broke that particular build. But now you have all these other 50 changes. How high is the likelihood that the build is broken again? They were lucky when they had every 2 weeks a new year, right? So at the same time, they said, we're going to introduce Scrum. So how does this work, right? When you have feedback cycles between, let's say, business, can you turn this text field a little bit kind of to the right, and then the person has to wait 2 weeks to see if that really has worked. And so this company was on the brink of losing the capability of shipping software, right? So they wanted to do Scrum to have a kind of evenly distributed feature flow. The reality was, because of the crappy build infrastructure, the reality was QA had nothing to do at the beginning, and before the release, all this craziness started, and then a long freeze period to get something out somehow. But the quality suffered so much that the customer said at one point, and they have pretty powerful customers in terms of they sell software for a high price to a not large-sized market. They said, we've lost trust in your new versions. They just cause too much trouble. But we want some feature from this latest version. So now they have 15 branches to maintain, right, for different clients. And it's just, should I mention that they have been on ClearCase for version control? Yeah. So I don't know how long you would stay at that place. It's heartbreaking. They have some people, not everyone, is very passionate. Is passionate about creating good software, and it's just killing them. And so you can't develop software like that. Period. And the reason why they have this problem is the crappy build infrastructure. But now the side effects, besides the one I've just described, are also more subtle, because the good developers say at one point, screw that. I have something better to do with my life. I leave the company, and the developers that enjoy such a situation, they tell their friends, I never had so many cups of coffee in my life. That is a serious problem. So I would say, from our experience, and we do consulting in that space, so we see many organizations. I would say the inefficiencies are significant, and they range from that you are in a reasonable state to ship software, but still have major inefficiencies, to the point, as I said, that you are on the brink of losing the capability to ship software. And so people might say, oh, it could be worse. There's still one eye, still one nostril for breathing, right? So, but the future will give the octopus even more arms. The software code bases are growing and growing. Right? We see typical growth rates for some of the largest software stacks we are involved with between 20% and 100% per year. I'm not sure what the situation at your organization is. But if you have serious problems now, if you now have a 6-hour build and your code base will be twice the size in 4 years, at one point, you're dead. Right? You're just about not to die, and at one point, it will kill you. Right? So, and those growth rates usually means that the teams are also growing, right? Making the inefficiencies ever more expensive, obviously. So, so if you improve the build time, what they did with Gradle, from 6 hours to an average of 20 minutes, if you have 200 people, you get more money out of that investment than if you have 100 people, obviously, right? So growing code bases are a big challenge you have. The other challenge is things getting more complex. So the set of technologies you need to support for creating software is diversifying more and more, right? So what has been a pure Java stack 5 years ago, and I think Spring, with their experience, can completely confirm that. In the old days, when you did consulting, it was, I'm sure you had many Java shops only, right? And now it's at least iOS and Android, but usually some Scala here, Node.js there. So in the old days, heterogeneity was considered a legacy burden. Now it's basically embracing the future of the technology. So the modern enterprise stack is heterogeneous. Whether you like it or not, you have to embrace that fact, right? And I think to some degree, it's a function of that software is eating the world, right? Software is doing more and more. You need specialized tool. So heterogeneity is a fact you need to embrace. And the key area where you need to embrace that is with the developer tooling. You can't have separate build tools for Java and for C++ and for Android if you form one logical, coherent software stack with those technologies, right? So, so that is a big problem enterprises are facing, the heterogeneity, right? So the other is also an architectural change, a change towards a microserver design, the whole move to the SaaS, right? That is from a software delivery point of view, it's much more challenging to choreograph the delivery process for a microserver design than when you ship one big ear to the client, right? So that's another complexity you have to face. And there's only one way to properly solve this. You need a true multi-platform build system that is also a very powerful orchestrator of the delivery process. And those are the very strengths of Gradle. So it's the only true multi-platform build system. And it's interesting that the companies that are most faced with that are the gaming companies or companies like Prezi, right? They have the most diverse software stack you can imagine, right? So and those were companies that in the old days created their own build systems, right? Because that was the only way they could solve their problems. And significant amount are now moving to Gradle. For example, Prezi, although my keynote is not with Prezi, I really like that tool. They fully switched to Gradle because for those very reasons. Oops, what happened? Ah, I know what happened. Yeah, so they need to ship very rich local clients for all different platforms to a rich service layer. And if you're interested in that, Prezi presented at the Gradle Summit this year how they're doing this. And the video is on the Gradleware channel at YouTube. So, but there is no question that there is a lot of exciting stuff we can do to make Gradle a even much better tool for those scenarios. And that's what basically the 3.0 vision is about. But it's never a free lunch, right? Build infrastructure is always organization specific, right? It's not like, to give you an example, one of the most efficient software development processes on large scale has been created by a company called Google, right? But for their radical process, everything is released from head, for example, everything, right? You need 5,000 developers of the quality of Google. You need a test suite. You need a culture that accompanies such a radical approach. You can't just say, oh, this is the best way to set up a delivery process. Yeah, it is the best way if you have this quality of people. If you don't, you're screwed. You can't release from head, period, right? And if you have a legacy software stack without a decent test coverage, you also can't just say, oh, from tomorrow we do it like Google, right? You have to model your delivery process according to the realities of your organizations. Whether you like them or not, that's something you have to embrace. And then I think a good delivery process can then also change the culture to some degree. It attracts the right people, it sets a clear focus on productivity, but initially you definitely have to embrace it. And it's when companies reach a certain scale, it is unusual that they can maintain a homogeneous quality across all the projects they have. So and then you have to be smart in saying whether you want to have stronger integration pressure or where you don't want to have stronger integration pressure. There is this one project only produces crappy software, but the project lead is the son-in-law of the CEO. That is an organizational reality, right? You have to embrace. So I don't want to do continuous integration with them. Definitely not, right? I want to shield. I want to use the old version because otherwise I can't get my job done. So the reality, you have to create your delivery process around the reality of your organization, and that's why our approach is not to provide you this one big framework that knows how your organization is structured. We don't know, but provides you a richer and richer toolkit that you can model it according to your needs. That is our mission. So you need to invest. There's no way around that, but we want to make this investment for you in a way that it's the minimum you have to do to get the enormous benefits. So to give you a real life example, kind of a positive outlook, what can be achieved, there's an interesting article in Wired connecting the commercial success of LinkedIn strongly with their investment into their build and delivery infrastructure. So we are very happy that Gradle is an important part of their infrastructure. So let's look at one of the things they have achieved. In 2011, it took LinkedIn 30 days to release a new version of their software. I would say for a couple of hundred people developer team at that point, they're now 1,000, but I think at that point they were, I don't know, 300, 400, 500. That is good, I think. So definitely way above industry average. If you look at that number, one thing, it tells you that if a new feature was finished, the average time it took the new feature to reach the client was 15 days, right? So they were in a very functional state, but they were much more ambitious. They are now able, inventory term, they're now able to have 2 releases per day. So this means the inventory term of a new feature reaching a client is now 0.5 days. This is a revolution. It's a factor of 30. And they were coming already from a very healthy state. Now imagine you compete with such an organization, right? And you are not able to pull that off. You have a serious problem. The way many organizations get away with the fact that their delivery infrastructure is very inefficient is that the competitors are not in a better state, right? But that is going to change. So either for you it's a unique opportunity to get competitive advantage, or you have to catch up soon because your competitor might be there before you, right? And then how does competition work? You get inspired by features, of your competitor, and if this inspiration process is taking place here, and they are much faster able to deliver the software, you have no chance. You're going to lose, right? So, and this is just one aspect, the time to market aspect, right? The whole developer productivity aspect is of course another major concern for them. How can we make the developers more productive? Because it's so hard to find good developers, right? So it's not just, you can't just even say, okay, then we buy 100 more good developers. They're not around. So you have to do everything to make them more productive. Again, there's a good video out there on the Gradle channel talking about how LinkedIn is using Gradle to achieve their goals. Okay, so now let's talk about the Gradle roadmap. So we are convinced that Gradle 2.0 is the best enterprise build system out there. I am absolutely convinced about that. But we are far from done, right? So when you hear Gradle 2.0, you might think, okay, that is basically from there on its evolution. No, absolutely not. Where we see ourselves is we are still in the base camp. So our goal is to create the ultimate build system, and Gradle is not the ultimate build system yet. Not what we think the ultimate build system should be, and we have always envisioned. So there are some major missing ingredients for that, and this is something a lot of that is something we will tackle over the next 6 to 12 months. So to give you some background, we are a small organization, although there are a lot of contributors. The key committers of Gradle work for Gradleware. So we have this vast vision, but we have this limited bandwidth, right? So, and in the last years, that was sometimes frustrating, right? That we couldn't get the speed to get some of the exciting stuff we wanted to get done. And so the situation for us has now changed significantly due to the fact that we have established really rich and valuable open source partnerships. So, for example, we have open source partnerships with LinkedIn, we have open source partnerships with Netflix, we have open source partnerships with a few other organizations where we have an NDA with. They never talk about their open source engagements, but serious organizations, to put it like that. And that gives us bandwidth in terms of, they say, okay, you want that feature, we also want that feature faster. So we basically sponsor development of features, and we can now massively increase our R&D bandwidth, which is super exciting, right? So, and that means we have a completely new R&D bandwidth to tackle those features. And we can be now much more ambitious and aggressive when it comes to the timeline of our roadmap. So that's very cool. Okay, so the first thing we are working on right now, and if you go to Gradle Masters, you can follow that, right? That is not whiteboard bullshit. This is happening right now. A new configuration model. This will be the biggest change since the inception of Gradle. Peter Ledbrook was the attendee of the first ever Gradle class in London. Remember that at Skills Matter? And you proposed, you said, oh, the configuration model, you have to do something kind of to make it kind of more task-oriented and whatnot. So that is finally something we're now tackling. Yeah, the thing is, I mean, you have to be. The old model took us a long way. I mean, look where we are, right? So, and you have to. It's always a trade-off with every feature. You know that situation from your own work. There's a lot of stuff that would be great, but it's always a trade-off. What do you don't do instead of that? So and I think we now also have a much better understanding how we should do it. So we are completely on fire to get this done because it solves so many problems at the same time. Right? So the first thing we want to solve with that is zero configuration time. This is driven by two major scenarios. I understand that most of you not from large development teams, but one scenario for us are large and very large projects. So I mentioned already the LinkedIn build with the 4,000 sub-projects. I'm sure it's now 4,500. It's an old number. And I said they managed to get the build time down with Gradle tremendously, but it takes way too much time for Gradle to configure it and get started. So it's a pain in the ass for them, in any case. So this needs to change. And that's the case for many larger multi-module builds. And even for smaller ones, if it starts 5 seconds earlier, that's nice. I want a responsive system. But the other scenario affects everyone. And the other scenario is deep IDE integration. So I think Android Studio, Gradle integration, is the future of how IDEs should integrate with build systems, right? And for such a deep integration, the IDE needs to continuously communicate with Gradle, continuously ask questions. Hey, have you added a new Android flavor? Have you added a new dependency? What has changed, basically? Is there a new version conflict, right? Things like that. And the problem at the moment, for each of those questions, Gradle currently always need to execute the configuration phase. So if you ask, if something is asked, Gradle needs to run the build to give the answer because there's not enough structure in there. Theoretically, someone could have in a build system for the version number something like system get current time millis, right? We don't know that. And if something is in there, such a dynamic part, there's no way we can cache the results, right? So we have to rerun it to be sure that the results are accurate at the moment. So, and that means even if this is only 1 second, it is already a pain. You don't want to wait 1 second for your Gradle view to update or for the IDE to act, because if the IDE is completely married with the build system, then yeah, this has to be faster, right? So we want to provide basically immediate responsiveness, 0 time for that. And so that basically affects basically all our users, that we get to 0 configuration time to make Gradle much more responsive, scalable with large builds, but super responsive for IDE integration. So that is one reason why we want a new configuration model. The way we're going to achieve that is with having a richer model. So you all use Gradle, so or most of you, so you're aware of the input and output capabilities of Gradle. Every task has inputs and outputs, and we can figure out something has changed, something hasn't changed, and if a task depends on the output of another task, the dependency is automatically created between those tasks. So, and exactly that is what we want to do for the configuration logic as well. We say the configuration logic are not those plain Gradle build script that have no structure, but we say, hey, we have snippets of configuration that have input and that have output. And then if I have such stuff like system current time millis, I can tell Gradle, hey, don't cache that element, right? But all the other stuff can be cached. So the key thing of achieving that is caching the model. But there's also other goodness we get out of that. I talk about, in terms of configuration time, I talk about that later. But the key thing is builds are rarely changed, and so that builds are just executed without changing them is the much higher proportions, right? So if you can cache the model, that will solve the biggest problems in that area. The other reason why we want to do a new configuration model is what we call next generation extendability. So Gradle sets already the bar when it comes to rich extendability. I mean, you can do amazing stuff in adapting Gradle to your requirements. There was always one of the visions of Gradle, embrace the unanticipated. If you look at enterprises, there are so many things needed you can't anticipate as the build infrastructure provider. My favorite example is always 70 people team, and they had this one very important test. And one test method had the following behavior. When you run it the first time, it always failed. When you run it the second time, when it then failed, the test was considered failing. Otherwise, it was considered succeeding. You cannot say, oh, stupid guys, you know, a member of their team was Stefan Faber, the founder of Mockito. You don't have to tell them that this situation is not what it should be. But again, it's a reality of the enterprise. It was a large integration test. Another team was responsible for the test fixture. So there was nothing they could do. There was just the damn reality they had to face. They didn't need a tool that tells them, this is not what the situation should be. Well, they know it themselves, but that was the situation, right? So you need a tool that can elegantly embrace that. And with Gradle, they could have elegant solutions for that problem. So that is a key vision of Gradle, embrace the unanticipated. Provide out-of-the-box behavior, but then also be able to embrace the unanticipated. So that is already a very strength of Gradle. Like no other build system on the planet has anything similar. But the requirements for us are also increasing. So a good example is the Gradle Android plugin. The Gradle Android plugin is not a normal plugin like the Find Plugs plugin. It establishes a completely new platform on top of Gradle. Right? The same is true for the Gradle native plugins. So now you have a situation, the Gradle Android plugin extends Gradle. And then you have, let's say, Android cloud testing providers that want to integrate the Android platform with their virtual devices in the cloud. So this plugin extends the Gradle Android plugin. And then you have organizations using all those plugins and also need to do some final customizations in their Gradle plugins. So, and if you have such a massive extendability requirements, our current model is a little bit creaking. So for example, the after evaluate section is too crowded and you have ordering issues and stuff like that. So we need to do hacky stuff, and where you introduce fragility into your build process, we don't like that. So, and with the new configuration model, we address that issue by basically saying configuration is not just some flat configuration logic where you then have a single after evaluate hook to put in stuff that should be done after the normal configuration is done. That doesn't scale. So the way we're going to do it is that also the configuration logic, like the execution logic, is a directed acyclic graph with configuration actions that have dependency relations between each other. That's what works well for the execution phase, and it's also what we need for the configuration phase. And by the way, it's one of the things that is at the moment often confusing to people. They configure a Gradle task. Let's say they say jar curly brace and then do something. For example, reach out to some repository to include the jars that depends on that jar to create a fat jar, and then they wonder, that this is also executed when they do a Gradle clean. So, and that's what many people think, I thought this is only related to the jar. Why is this executed all the time? So I think the new model will be also more intuitive. There's one big graph of things that is executed. And that gives you also all the richness to solve the ordering issues I've just described, right? And then for example, the Android team can say, I want to have the final, the Android plugin can say, I want to have the final say, and I want to do the last configuration validation, right? And then they can say, I want to be the final configurer, and if someone else also says, I want to be the final configurer, the build fails, because there can only be one. So this is really cool stuff. Whether, and it is relevant for the whole Gradle community, either because you have complexity that requires it, and you have now a really sharp tool to model that, or you can enjoy much better platform plugins that do a much better job for you, even if you don't use this hooks for yourself. So the next thing, parallelization. At the moment, Gradle parallelization is per sub-project. This is too coarse-grained, right? Particularly when you look at how Gradle is pushing more and more the concept of variants. So what we say to many organizations, if you look at the refactoring book from Fowler, there's the lazy class smell, and we say there are too many lazy project smells, for example, in Maven builds, right? It's a heavy abstraction, so often you should do stuff in one sub-project. So the Android plugin is pushing that a lot. So when you for example, have a simple Android application, but what you have is you have a free and a paid version, right? So if you, for example, set this up with Maven, you have a 5 sub-project build, right? One for the core, one for the free, one for the paid, sorry, 6. And then you have testing sub-projects for all of those variants. It's a complexity for a tiny Android application that has just this little variation where we say this should be in one project, right? This is not worth to have this heavy abstraction of a sub-project. But no, at the same time, we say, but if you want to have parallelization, right, you need to have it in sub-projects. That kind of is not what we want. So, variants, and we'll talk about that soon, will also get more and more interesting for the Java domain as Java is getting really innovative again, right? And so that's and one issue we have with our current parallelization approach and why we have it so coarse-grained is that otherwise it would be too fragile. If we provide fine-grained parallelization, we want to do it in a way that you don't need to bother about that. We could easily say, oh, we parallelize Gradle on a task level, and here's a log annotation you can put to your build logic where it's not thread safe and stuff like that. Then that is not how we want to do that. We want to provide you a deep and rich framework where Gradle then can figure all that out by itself. And the new configuration model is a key enabler for that, because with the new configuration model, we have a much better idea at what point do we have reached immutability, and at what point, and we can also exactly know the inputs and outputs and how they depend on each other. For example, if we have 2 tasks that are not dependent on each other, but write into the same directory, and one task, for example, is cleaning the directory before it writes into that directory, you have a problem when you run them in parallel. So you need a model, a simple model but powerful model where our users can describe those facts, right? And then we can figure out how to solidly, in a rock-solid way, parallelize the stuff. And the configuration model is key, because another thing that you see is because of ordering issues, sometimes people do final configuration at the execution phase. Right. And when you allow this to happen, then you can't parallelize, right? Because then all different weird behavior is introduced. So with the new configuration model, there is not a single reason anymore that you need to do configuration in the execution phase. So we can lock, we can make the task model immutable at some point, and then we can parallelize it, and at one point in the future distribute it. So yeah, once parallelization is switched on by default, we have Gradle 3.0. Which will be as delicious as the birthday cake for my 3-year-old this year. Yeah, so, and that is the clear goal parallelization must be so solid that it's switched on by default, that you even need to, that no one needs to think about it, right? That is the goal, and we're working on that. And the new configuration model is an enabler. So what about compatibility? You might wonder, is this now kind of a tapestry style project? No, definitely not. So we will continue to support the current configuration model for a long time. And additionally, we will provide a way to map the current DSL, because the DSL will change, to the new configuration model to enable a step-by-step migration, right? So nonetheless, we think the benefits of the new configuration model are so outstanding that people will move towards it very quickly, I think. And we definitely move all the core plugins to that. We're already in the process. So just to give you an idea, the whole native plugin has already been switched to the new configuration model, which is the most complex plugins we have besides the Android plugin. We're working on migrating the Java plugin. The Android folks are working on moving the Android plugin to the new configuration model. So this is happening right now. I can't wait to see the performance numbers we get out of that. So yeah, that's the new configuration model. Next thing I would like to talk about is the new component model and variant-based dependency management. So what use cases are we trying to address here? So for example, an Android application is assembled into multiple build types such as debug or release. A Java Enterprise application could have the same requirements, right? One is kind of bundled for Tomcat, which is run on a development environment, and then for some end users, they need also to be a WebSphere version, right? It's a typical scenario. And those are not the same packages. They might have some different configuration information, or they have been compiled in a different way, whatnot. So another, I guess, use case many of you are aware of, a library is compiled and published for multiple Scala or Groovy runtimes, or for multiple JVM runtimes. It's not an easy problem to solve nowadays. It should be, right? But it is not. You have to do a lot of manual stuff to get that going. I already talked about a scenario an application is tailored for various purposes, right? So like a free and a paid application. Another interesting scenario is a library is composed from source files in different ways, right? So for example, some source files are compiled using the aspect-J compiler, and other source files are compiled using the Java-C compiler. But the resulting class files should all belong to one library. And another use case, a library is implemented using a mix of Java, Scala, and Groovy, and then these source files are jointly compiled to produce the library. We want to make all that high-level concepts. We want to give you a high-level DSL where you can simply describe such scenarios, right? So that is the new component model. But this goes further because it also affects dependency management. Right? So for example, when I say this library targets the Java 8 platform, and now I have dependencies on many other libraries, and those libraries most likely at one point, as Java 8 is getting more and more traction, will have also a variant, right? So there might be a full library that has a Java 6 variant and a Java 8 variant. So what you want in the whole transitive graph, that the dependency management is variant aware and picks the right variant of the library you depend on. In a native world, this is a no-brainer. That is the reason why there is no good dependency management out there in the native world, because they need that, of course, all the time. And that is what also driving our variant-based dependency management. But also in the Java world, in the Scala, in the JVM world, this is, I think, a much required feature now that Java is no longer dormant. Right? So, and of course for Android it's also super important. So, yeah, we think, and JavaScript needs that, and so we are super excited about that. Again, there is an interesting talk about that in the Gradle channel at YouTube. And then, yeah, we want that you can do stuff like that. Hey, JVM, I have libraries, mylib, it should target Java 6, Java 8. Right? Then I have some native runtimes where you do some JNI stuff with. Boom. This is how you will be able to do that in a couple of months, right? So we also model the concept of a platform, right? So for Java, for Android, for C++, that we can do a lot of interesting stuff. So, and then this information we can use for environment setup and stuff like that. So basically the idea of the component model is to just model in a much richer way the things you work with as a developer every day. And then we can make your life so much easier, right? So, and at the moment, what Maven and also Gradle does at the moment is to say, hey, I have a Java project, right? And then we create some conventions, here are the sources, then we create a jar task that implicitly bundles the compiled classes, but it's not deeply connected. And what we're saying now, that the build definition should be much more driven by the things you want to get out. So you don't start with the sources. You say, hey, I have libraries. I have a library, mylib, which targets those two different Java platforms. And then we create the conventions. We say, OK, then we assume that there is a source mylib directory with the sources for mylib. And then we assume that there is a source mylib Java 6 directory and Java 8 directory for the variants of that library. So this triggers a whole build by convention chain, right? But driven by the fact that you say, I have a library, right? So, and that will make many scenarios so much easier for you as a developer to describe. And yet have not a kind of free-floating end situation, but a very structured build by convention approach, but with the flexibility you need nowadays with the requirement you have nowadays. We're no longer in 1998. I mean, and the build systems, in a way you describe software projects, they haven't quite caught up yet, and that's what we're going to do with that. And with that, then the source object, the domain objects of Gradle, the sources know exactly, oh, this source object is related to that library. So when you then apply the Gradle code quality plugins, right? With that rich system, they can also immediately adapt to that. They can ask Gradle, hey, what JVM libraries do we have? Where are their sources? And can function in a generic way. Although you have a lot of flexibility here, they still will provide you the right reports for all the libraries you have defined. And that can only be achieved with a rich model. Another wonderful thing of such a rich model, if you think about IDE integration, right? We get so much interesting information out, we can then visualize in an IDE because it is modeled. It is not implicitly hidden in some task. It is modeled by proper abstractions. So we will continue to invest heavily in a Gradle native support. This is also very relevant for Android. So if you write native Android extensions using the Android NDK, right now this is supported via makefiles. And we are very excited about the fact that Google Android team is working now on switching the NDK support for makefiles to the Gradle C++ plugin. And once released, this means Gradle will immediately be one of the most important C++ build systems in the world, right? Just from day one. That's pretty cool. So, cache everything. Gradle is already doing a great job when it comes to caching the build output and building incrementally, right? So all of you that use Gradle know that. You have all this nice up-to-date stuff. And now we want to push this 2 steps further. So currently, any build output you have is locally cached per build. And I'm sure many of you run in the following situation when you have a Jenkins instance, right? You have let's say, a little bit of a larger project. You want to have multiple Jenkins jobs for this project. So one job that is just doing to compile and maybe some fast unit testing, to give initial fast feedback to the developers that something is broken, and then the next job that does some deeper quality checks, however you want to partition that. The situation you have at the moment is that all these Jenkins jobs, they basically have their own workspace. So the job that is doing the integration testing does the compile again, creates the jar again, and can't reuse the output of the other job because that was happening in a different workspace. Make sense what I'm saying? So And what we want to provide is that we say, hey, for every output, not just what we do for the dependencies that we retrieve from the repository, for every output of the build, there is a global cache per machine that captures all the Gradle output and can be shared between all the Gradle builds that are running on that machine. So for CI jobs, this is really helpful to make them more efficient. And as a next step, we are going to distribute this cache, right? So that means any build output will be able to be shared across machines, and that is really cool, right? So let's say so currently the Gradle incremental build, you check something out from version control, and there's new code in there. So regardless that you have done a Gradle build before, Gradle will do a full new build because the input have completely changed. In the future, and not too distant future, what we will do is we check, okay, what commit ID has the code you just checked out. Let's see in a Gradle distributed cache whether someone else has already built that jar, and otherwise just get it from there. There's no point in doing that yourself again, right? So that is a really a feature we can't wait to implement. Work on that has not started yet, but it's very important for us. And the shared outputs will also include the output of the configuration task. So I talked about a new configuration model. So then we can even share the Gradle model via a repository across all machines. So really cool scalability feature. Google introduced that concept 6 or 7 years ago with their own build system, internal build system called Blaze, right? And it makes a lot of sense if you need to scale up. And so that's pretty cool stuff. What is really important if you do that, so it makes only sense when you want to have such a cache. It must be 100% reliable. 99% is not good enough. So what you need to be able to do if you provide such a cache is not just capture the output of the build, but also the inputs that created the output. So the compiler version, operating system you're using, etc. If you don't do that properly, if you don't have a rich model to capture that, that will be just a toy, and people will disable that after 1 week because it always screws them out. But if you really have a rich model and can completely capture the input properly, then this will work amazingly well and will be a really cool feature for medium or larger software stacks. Gradleware will finally invest heavily into improving the tooling support for Gradle. So Spring Source, am I still allowed to say Spring Source? Okay. Can't get over the good old days. Started the Gradle plugin for Eclipse. So that was really helpful contribution for us. We had no bandwidth for that when they did it. And we now basically taking over the effort. And so work on that has started right now to make Gradle Eclipse support not just rock solid, but also really innovative and with a lot of cool features you can't have from other build systems. So who of you is using Eclipse? Just curious. Yeah. So something to come soon, I promise. Because we have all these wonderful possibilities with the tooling API, the work we do for Android that makes it pretty straightforward and simple to do cool stuff in Eclipse, but it just has to be done, and we're now doing it. Okay, so finally, Gradle plugin ecosystem. The build domain is a domain with infinite requirements, right, that are constantly changing. So a rich plugin system is key for the capabilities of a build platform like Gradle. So, and we are fortunate that the Gradle community has already created a rich plugin system. So there's really cool work happening. The problem was we didn't provide any nice way to make that work visible. So our plugin portal until June was a Confluence wiki page. So not very cool. This has now changed, and I want to point to two major things that happened in that area. So one is the Netflix Nebula effort. See if I can, no. So Netflix is a big user of Gradle and also a big contributor. So they have created what they call the Nebula build language plugins. So those are plugins they have. Not so good, right? Sorry. So they have created a number of really cool Gradle plugins that are relevant for many people, for a large part of the Gradle community. An OS package plugin we hadn't have, some really nice info and project reporting plugin, quite interesting stuff in regard to dependency management, blacklisting plugins, closure, stash plugin, some cool stuff to manage your Gradle build environment with so configuration helper. Then interesting metrics plugins. Then really interesting to check out a dependency log plugin. So with that plugin, you can basically log the resolution process and can commit that to version control. Something you know from, if you know that from Bundler, for example, right? So this is now functionality where you have an equivalent in Gradle. At one point, with some modifications, we want to move that functionality into Gradle core, but let's see when we get around to do that. But there is now a possibility to log your dependency graph with a log file and so have a 100% reproducible build, even if you use dynamic dependencies, right? So basic SDM plugin for accessing version control system via Gradle, and damn, they took over Gradle. No. So really interesting stuff. And then the other thing that we released recently is our plugin portal. So it's the first iteration, but finally we have a plugin portal. And it's not just a new plugin portal. So for example, if you click at this plugin, something else has changed. What is new? So first of all, you can read about it, what it's doing. We have a reasonable deal with versions. But what we also introduced is a new plugin system. So our goal is that there should be no difference between core plugins and external plugins. At the moment, when you use a Gradle core plugin like the Java plugin, you just say apply plugin Java and it works. When you use the Android plugin, you need to have all this kind of build script stuff. If you right? So it's always a pain in the neck to apply an external plugin that is not part of the Gradle core distribution. This is why the Gradle core distribution is so big, because we want to make it convenient to use the key plugins. But we hate that it's 50 megabytes, right? So, and it's not because it's a monolithic thing, Gradle, it's just for convenience for our users, because I think they rather download a large chunk of a distribution than to always do this. So, but that has now changed into one. So you can now just say plugins ID, and then provide an ID and a version, and then we automatically retrieve that from the Gradle plugin portal. So, but there is more behind that. So it's not just a more convenient syntax. We deal with plugins now in a very different ways. In the old days, this is just a method that is called. So this is not a declaration of a plugin. That just means execute that method of that plugin class. This section here is now processed before the build is executed via Groovy AST transformations. And it means you now really declare your plugins, and before we execute the build, we know already which plugins you are using. So again, a wonderful opportunity for us to provide better tooling support for that. One of the challenges of not using XML and using Gradle is to still get declarative information out in an easy way that you then, for example, can use in tooling. And also in an efficient way. So we are increasing our capabilities. Right? So yeah, so we are super excited about that, and there are now, I think, already 140 plugins in there. There's still plenty plugins that haven't migrated there yet, so I'm at the moment reaching out to all the plugin authors to move all their stuff there. And there's a lot of functionality we are planning. There's also, what we also do with the new plugin portal, plugins have a very specific set of metadata in the binary repository. So we want to enable stuff like that plugins can say, I work with this versions of Gradle, right? And then if you use a different versions of Gradle, the build will fail, or you will get a warning. This plugin has not been validated to work with that Gradle version. So there's a lot of goodness we're going to provide for the plugin, for using plugins with Gradle. And finally, we will get the Gradle version, the Gradle distro, much smaller. Yeah, I think that was anyhow the last thing I wanted to present.
Can I ask a question about that?
Yes, of course.
Can the plugin repository be mirrored if we have it incorporated to the main repository? Does it have to go live to the plugin repository on Gradle all the time?
So yeah, so the problem at the moment, this is only for public plugins. So for organizations with private plugins, we have to we will provide something. We don't know exactly how this looks like. Right, but there will be a solution. Everyone is asking for that. So 100%, good question. I have, we have still some time. So I have 3 Gradle books to give away. Yeah, that was everything I wanted to say. So we have 3 Gradle books to give away. So the first, you already get 1, and 2 more for more questions. Please. You're not thinking about the question you're asking. Okay, so yeah, please.
There was a comment made in another session that Spring Boot is configured to use Maven automatically. Making the effort to integrate Gradle with Spring Boot, or what's the effort there?
It is integrated, so you can use both with Spring Boot. And I think Netflix is really pushing this hard, because no, we had some chats with the Spring Boot team. I think there's amazing stuff you can do in conjunction with Spring Boot and Gradle. So what we have just shipped into 1 is the first, I think I can say that, the first rock solid incremental compiler of any Java build system, right? So we have now in 2.1, it's still incubating, but it's already used by LinkedIn, for example. In 2.1, there is now a Gradle incremental compiler that does bytecode analysis and source code analysis to have an extremely solid incremental compile that only the classes needs to be recompiled that are affected by your source code changes. I mean, and Maven have an incremental compile in a way that it looks for the timestamp, what has changed, and then only recompiles that class. But if another class depends on that class, things might break. You know what I mean? So the point is now, 1, there are 2 scenarios why we do this. One is to have a faster compile time, but the other is to work with tools like Spring Boot or JRebel that they know which classes to reload if you have changed the sources. That makes sense. So in the old days, if you integrated JRebel with Gradle, when something has changed, we recompiled everything because that was the only way to reliably do that. And then JRebel had to reload everything. Now with this new feature, JRebel can be much faster, and something similar can be used then by Spring Boot. So I think there's a lot of cool stuff we can do. So we have a relationship with the Spring Boot team. Gradle is supported with Spring Boot, and I'm looking forward to the day that Spring Boot is really using some of the innovative things Gradle can provide to them, so that it's not just basically the feature parity, but that they can really use the unique capabilities of Gradle for stuff that you can't do with another build system. I think it's just a question of time, but it is supported. Yes, please.
The variant feature that you were talking about?
Yes.
Is that similar to maybe qualifier or something?
Ha, good question. No, because with Maven qualifiers, this is used for stuff like Java doc or sources. The problem with qualifiers is they can't have their independent dependency graph, right? So if you would like to model that with qualifiers, you can't say the free Android or let's say the Java 6 variant and the Java 8 variant might have completely different dependencies. Java 6 might use some retro library to get some of the Java 8 features. The Java 8 variant doesn't need that. Does it make sense? So they can have completely different dependency graphs. That is something you can't model with qualifiers and is absolutely required. So you can try to map some of that with qualifiers, live with the limitations. For Java, it might work. For the native and Android world, forget it. It's just pointless, right? So the way we will implement that, our new dependency model is, we will allow you to tell Gradle how it should be persisted, right? If you say, please persist your new model with the POM and with qualifiers, we try the best to do it, right? But it might not work, or you might have a not so good experience, or you use a much better format, right? So, but at the end of the day, it's your call. We're not trying to impose something completely new, but Android and the native domain, they anyhow don't care about POMs, right? They're completely open to a proper dependency format, and then the Java people can decide whether they want to persist things via POM, via Ivy, or via a new metadata format, right? But there are limitations, and you have to accept. Yes, please.
Question regarding the configuration model. As far as test execution is concerned, do you have any future plans to add some features or some kind of functionality that will allow text execution results to be stored into the database without doing any workarounds?
So to store test execution results in?
A database, any database of choice, whether it's Oracle or SQL Server.
So the test results XMLs or what exactly? What?
Well, the test data.
The test data, right? So I would say, I mean, one of the big pain points in general that we're seeing in the enterprise is how to deal with integration testing, right? So, and there are two challenges, right? One is the test fixture setup, and the other is to deal with the variance you have in integration tests. You might have fragile integration tests, you might have stable integration tests, you have integration tests that are only relevant for one platform. So in general, and again, Android is also pushing that, we want to provide, you can model this already really nicely with Gradle right now, but we want to model much better functionality for that. So for example, if we've started to model a concept of a platform, right? And what we're also starting now is to model the concept of a service, you know, and you can have service dependencies. And when you have a dependency on that service, we know exactly that service needs that fixture, etc. But the details of the test fixture, like the test data in a database, that's not our cup of tea. We would choreograph that, but how you get that test data in a database, whether you know there are enough libraries out there that try to solve that problem, you would just integrate them with Gradle. This is nothing we would tackle explicitly.
What about the actual test results that Gradle generates?
Yeah, so
What he means is rather than producing HTML or XML reports, some programmatic API that can listen for it and be able to do whatever we want.
okay, that's the tooling API. That is the tooling API that will provide you exactly that. You can execute tests via Gradle, get events, and then do whatever you want. Yeah, and you could do this right now. So Gradle has a rich, so not with the tooling API is a separate thing. It's tailored for integration with the IDE. You can deeply integrate with Gradle test execution, right? The Gradle test tasks have listeners, so you can say, inform me about this, inform me about that. You can write right now, today, a Gradle plugin that gets the results in real time from the test execution and does something with it. For example, if there's a failure, fire up my editor with the test results XML, or push something to a database, or send email, whatever. So that is something you can do. You can do right now. Yeah. Yes, please.
So at the beginning of the talk, you talked about an application these days has a lot of different components to it, different languages and whatnot. What is the suite of languages that Gradle is targeting beyond just Java?
Yes, very good question. So at the moment, it's the JVM, so it's Java, Groovy, and Scala. Then we have Android, which is a separate ecosystem, right? Java related, but it's not JVM. Then we have native world I talked about. And the other two major platforms we see, 2 to 3, one is JavaScript. So that's an interesting one because they have their own kind of build tooling, they have Grunt and now some other tooling. On the other hand, we think all the stuff we do with the, especially in the dependency management, is super helpful for JavaScript. So there is JavaScript supporting Gradle. We haven't had the bandwidth to make it in a way that we say this is another first-class citizen in the Gradle world. It has just started, but we want to make, we need to provide in some way outstanding support for JavaScript, either by providing functionality on top of an integration with a native JavaScript build tool or via a completely separate solution within Gradle. So JavaScript. The other thing, obviously for us, iOS. Right? There is iOS support out there, but it wraps around Xcode. And so we also already support Objective-C, so we made the first steps in that direction. I forgot to mention that. But I think what we want to do is really model deep also the iOS workflow. And then last, just to finish my answer, and then at one point do something with .NET. And that's it, right? The rest has to come from the community. So if someone asking, are you doing Adobe Flex? Say, has to come from the community, right? If someone is asking, what about Eclipse? Building Eclipse application has to come from the community. And there is now the Wolf plugin out there that is exactly doing that. But the platforms I mentioned, those are the ones we want to make first-class citizens in the core, and the rest will come from the community.
With JavaScript, you're talking about just generic JavaScript with runs and compilation, or more node side, node level?
Both, definitely both. Including support for NPM and whatnot. Just checking. 4 minutes left. Any more questions? Oh, that sounds good. Thanks for your attention.